Okay, fifth week, Revit and parametric modeling. Here are a list of what to do today, okay. Firstly, we're gonna have lecture, 2 parts, a brief review from the last week, and then we're gonna move to the BIM and parametric modeling, including some demos, okay, examples, and then lab exercises. Last time we haven't walked through this one, okay? Your name, this floor, Revit model using as a BIM authoring tool. By using that, we're gonna take some more modeling to make entire this building, okay? That's the one main subject for today's lab exercise. But lab exercise is just actual Revit and BIM modeling, but the lecture is going to handle some theoretical background and some advanced features and some more, even more issues such as BIM modeling after, what's next, something like that, okay? So let's quickly review from the last content. BIM and design visualization. Why we are using such advanced tools? Actually, BIM is in charge of handling entire building life cycle, okay? When kind of scratch mode, in other words, when we have just roughly generated plan, we have to elaborate plan and draw something, make something, such as floor plans and so on, and we have to plan construction, scheduling, budgeting, and so on, and actual site construction. From the site excavation, and then erect the building. After as built, the building is under the operation, okay, under the maintenance. At the end, probably the building is going to be kind of mid demolition. Anyway, that is building life cycle. But mostly you are in, actually, especially in the school design studio course. In the studio course, in terms of building life cycle, you are in schematic design stage, okay? Conceptual design level, conceptual design stage. Anyway, for designers, we still need 3D visualization. So that's why I put another emphasis on such BIM tools also support 3D and several type of visualizations. That's why I showed you this kind of render scenes generated by Revit. And another example. And actually this is floor plan view in Revit. This is another type of visualization. How about section? How about elevation? Some product details, they are one type of visualization. And Revit supports very intuitive and easy to use architectural building modeling, okay, compared to other general geometric software. So what if you create your building model using some libraries, interior finishes, material, and so on, and transform that file, geometry, to 3D Max, Rhino, SketchUp, whatever, for better visualization? It's kind of efficient way, okay? So this is one way of interoperable way to enhance such BIM tools for designers, architects, interior architects. So this is an example. And next time, we're going to deal with something like this lab exercise, okay? One of the lab exercise topic. Photorealistic rendering is also available, but the problem is currently it's very slow. But anyway, my point here is this kind of very elaborated photorealistic rendering is available. Simply use Revit only, okay? That's the point. So another thing I would like to bring your attention again is the comparison between geometric modeling and parametric modeling, BIM modeling, such kind of advanced things, okay? I showed you this demonstration, and you experienced this one, Autodesk homestyler.com. This is very easy to use, intuitive kind of home decoration tool, okay? But this is not just simple geometric design tool. I told you before. This is one type of BIM tool because this one contains amount of building information. This is homestyler.com web interface, and we have used this kind of easy to use interface. Just drag and drop or clicking options and put information and check the information, data, and simply adjust the parameters. At this time, the length of the wall, that's the parameter, and we can easily control the model geometry, okay? So what's the main comparison between CAD, simple dummy geometric CAD versus building information modeling? By using this homestyler, when you model this one, this is of course 3D and totally object-oriented. And one important thing is homestyler.com knows your object is a door object, okay, not just geometric shape. But actually, if you export that into DWG CAD file, and if you open in the AutoCAD model, this one is just a series of points, lines, in other words, just polylines, okay, simply defined by XYZ coordinate system, Cartesian coordinate system, just blocks of polylines, okay. But if you save that file into Revit, I told you this homestyler.com file can be saved into several files, including this Revit file, okay? So, and if you import that file into Revit, the door also recognized as a double panel door, okay? Totally different. This is the main comparison between geometry and building information model, okay? Building information model has object, double panel door, and its associated properties, sill height, frame type, material, finish, head height, and so on. What if you want to use such information for your design, update, for making better design, and so on? It's available, okay? And also this door can be provided by door manufacturer, okay? Not just designer. You can design doors, of course, but usually we use manufactured doors for your design. If so, why don't we use such available predefined objects, not your design? We can focus on your own design concept and some special shapes and so on, not just products, okay? You're not going to make some concrete material or concrete wall shape, specific shape. We can design surface or some specific type, part, but not entire product of that kind of wall or some structures. So all separated. This is the way of conventional representation of design, your design to symbolize the shape. This is conventional way of design. Probably in your design studio, you are still working in this way, right? This is not a bad way, this is good way, but conventional way. In a newly developed way, such as BIM or some totally computational way, so-called digital design. You may remember this course name is Digital Design, okay? Digital design aims to teach you there are something beyond conventional ways, okay? Anyway, bubble diagram, sketch, perspective, floor plan, axonometric, some type of symbolized way, visualization, still important. That is why BIM authoring tools such as Revit still supports auto-generation of those views, okay? They are just a view, not drawing, not a task. If you create computational BIM model, this kind of section, floor plan, axonometric, even diagram or SketchUp can be automatically extracted, okay, without any additional efforts. That's one great way to use such BIM tool. So in a nutshell, symbolized way, in CAD way, in hand drawing way, they are just geometry, okay? Those information. There is a symbol and there is a rule to recognize that symbol as real object. But in BIM approach, that is not just a symbol. That is virtual, real object, okay? In real life, there is a real object, and computational model contains that object. There is no symbolic shapes or some additional things. That is why Revit recognized this one is a door, and this door has some additional information and relationship. Revit knows this door is attached on this wall, not this wall, okay? Those two separate walls, and which one has a relation to this door, and so on. Also another way, this room has a connection to exterior space because of this door. That is another relationship, and computer auto-generated that topological relationship. So in terms of CAD history, I told you again and again the CAD history. We have focused on geometric shapes, okay? Even by using computers, let computers do what we have drawn. But in BIM approach, we changed, let computers do what we have done, okay? What we have done for everything for building life cycle, okay? If building is a product building has their own life cycle. Life cycle management is the main issue of BIM, okay? Not just focusing on design. But again, I told you, design and visualization is still very important, and that's why I show you some visualization and some designer-related features again and again, especially in the lab exercise hours. So another review, solid modeling and parametric modeling, okay? In Revit, you can make this kind of shapes easily because you have learned SketchUp, 3D Max, Rhino, or some other tools. Even by PowerPoint, you can create this kind of shape, okay? But if you draw something like this in SketchUp, and if you use push-pull and generate this one, that one is only for visualization. That one is surface-based 3D. But if you generate in Revit this shape, that one is totally solid 3D geometric shape, 3D solid shape. In other words, even if they are looking totally same, technically, in terms of behind technology, they are totally different. But actually, in Revit, you couldn't find out such modeling icons because it's kind of project management tool. But in Revit family editor or customized some sketch editor, such as sketch mode for drawing some object, drawing floor, you can find out something like this. When you draw floor boundary and click the create button, the specific thickness is going to be added and the floor slab going to be created. That slab officially, really solid, okay? There is no surface object in real world. So that's the solid object in 3D and Revit. Some smart solid modeling followed by this path. This one can be auto-rotated and generate this kind of shape. There is no surface shape, simply based on these shapes. Anyway, thanks to that solid model, we can take maximum advantages of Boolean operation. Boolean operation means this kind of void shapes, plus, minus, union, intersection, and so on. So simply bigger box minus smaller box, output is here, and some more examples. All they are Boolean operation based solid model. In real world, what if you want to make this kind of object? The easiest way is bring this box-shaped material and cut it, okay? That is the real way of production in real world. Even in computer, even in Revit, the same way, okay? No need to point out XYZ coordination system. No one here put the Cartesian coordinate point in real world on your desk to create this kind of form, okay? Make this one and cut them out easily. That is the real way of creation in real world by human. The same as Revit, it facilitates that kind of Boolean operation system like this. So next thing is parametric modeling as a review. When we are dealing with parametric modeling, there are amount of parameters, representatively length, width, depth, height, thickness, and so on, okay? Simply because our real-world product has them, okay? So by controlling that things, we can control features. If we control features, that object also going to be changed, okay? What we can do by using such parametric modeling, there is a part and there is a assemblies, which is composed of amount of parts, okay? That's the real way of real world creation, some creation process. And also there are some drawings, such as section profile or some sketch mode boundary drawing and so on. And there are some more concepts in parametric modeling, some terminologies. I told you some parameter, feature, part, assembly, drawing, and also constraint. Constraint means some specific objects constrained to specific geometry or specific situation. For example, in today's lab exercise, we're going to make entire building. And so far, we have level 5 model, okay? What if you copy such level 5 object to level 6? Simply change constraints, all objects constraints to level 5, simply change to level 6. And then everything gonna be moved without any issues, okay? So such terminologies within parametric modeling are still very important, but it's not easy to recognize, understand. So I'm going to show you some demonstration and examples. So according to this well-known CAD history, we spent amount of time for handling such geometric issues, okay? But in this semester, we have to resolve those rest of advanced parts, okay? Solid model, parametric model, and building information modeling. This one contains all prior things, okay? So we're going to deal with those parts in this semester, in this class. Why we need such advanced technologies? That's what I brought your attention. Nowadays, we encountered in our daily life very non-uniform designed, very good shape designed in our built environment, something like this. We can make this kind of form, shapes, by using SketchUp, even by SketchUp or 3D Max easily. But the problem of that is they are just geometric shapes, just for visualization. Without parametric design and BIM, how to make this building in actual site? Okay, that's the question. You can make this building design using SketchUp without any problem if you are skillful for using SketchUp. But the problem is how to measure the exact scale, how to count, how to extract this structural truss bar and the structural frames, quantities, and the specific shapes, and how to resolve the problem of manufacturing, and so on, okay? That's the main issue. In terms of building life cycle, usually designers are not in charge of this kind of engineering or construction issues. But what if your design couldn't be realized? In that way, your design is just virtual design. Nothing can be realized. Easy way is just to design everything in box shape, okay? The same as our modern buildings. But such kind of buildings are very common. If you want to create something like this, we need to, even if we don't know some structural analysis things or some details about engineering features, engineering issues, at least we have to know what are there and how to control such data, such information when you can encounter even in early design phase, okay? That's the question, and that's the reason why I showed you this kind of series of examples. There are some good examples by using BIM applications to take maximum advantages of such advanced tools. The first one, Phaeton building, the building's facade design, I mean this cottonal panel system design, they generated several design alternatives by using Revit and some similar software, and eventually they generate this one after making this one for based upon their series of design review tasks. Thanks to BIM application, they can generate series of design alternatives in actual and real form, considering constructability, okay? And next one, Korea Navy Museum. This one has some certain type of non-uniform design. Basically, the model designed by some geometric design tools such as Rhino, something like this, but imported into BIM application and put some parameter node to control points. And thanks to their parametrically defined geometry, they can manufacture this building surface piece by piece thanks to exactly counted, measured geometric shapes, okay? And this one is Plaza Hotel example. I told you the mullion. Mullion means the frame, okay? Frame of this window, curtain window. Any single mullion has something different parameters, different thickness, height, and so on. So total around couple of hundreds window frames, but they all controlled by one single spreadsheet and data set, and they can be separately manufactured and installed, okay? This is the other example. And another issue I want to bring your attention is BIM-enabled remodeling, reconstruction. If there is an existing building and there is only given floor plans, we need a building model, okay, for making something better building design, for renewal. How to make this building easily, quickly, and precisely? The one that I gave you last time, I gave you the floor plan of this building, and you recreated by using Revit quickly, easily, okay? And today we're gonna make entire this building, not this building actually, but thanks to advanced modeling tool like Revit, we can make this kind of building easily, simply based on given floor plan, okay, AutoCAD files. And then adjust interior or even exterior finishes, materials, or detailed floor plans and special allocations and so on. Just one scenario, just one of the possible industry scenarios, okay? So for this parametric design, parametric modeling, in Revit, we're gonna make some building model based on this floor plan, this building's floor plan, College of Human Ecology building, not actually your design. But we need to take a look something details about parametric modeling. For parametric modeling, we're not going to use family editor at this time. Instead, we're going to deal with Autodesk Vasari software. Okay, this is Autodesk Vasari software. Actually, this is currently beta 3. This is free software. You can download autodeskvasari.com website freely, and you can install this one. Currently, it's beta version, but actually this one is totally looking like Revit. And if you save the file extension is the same to Revit RVT, okay? And is totally compatible to Revit. But in this tool, you can find out some geometric shapes, mesh model, and editing mesh, and some geometric controls, okay? This is the screenshot of Autodesk Vasari. This one is looking like some products, but actually this is building scale, okay? The lines behind those objects are floor lines around 4 meters height, okay? So now you can see the scale of these objects. They are buildings, okay? Simply we can put and study building facade, simply defined by specific components and number of frames and so on, parametrically. And this is another mesh modeling by using Vasari. Of course, you can generate this kind of building meshes using SketchUp, simply using push-pull tool. But this is Autodesk Vasari generated. And there are amount of floor plans, floor levels. If you generate this model in Vasari, also very easy and quick, you can cut the floors and you can measure the area, and even you can simulate the solar study or wind tunnel based upon the Google Map location, geospatial information, and so on. And you can design, you can place your own building, and so on. Later on, I'm going to show you some demo, or one of the lab exercises, we're going to deal with Autodesk Vasari, okay? So I would like to show you some easy cases first. This is Autodesk Vasari. Actually, you can do in similar way even in Autodesk Revit. But this is anyway Vasari, but almost looking same to Revit. Okay, here is a simply generated building shape, which is rounded surface, front side. And if you want to create this side using this kind of window frame, curtain panel, what you can do. If you use SketchUp or 3D Max or Rhino, simply put some grid and some editable poly, geometric edits, you can make it. But the problem is computer and even you cannot recognize how many frames are there, okay, before you count one by one. But in this kind of parametric tool, if you define this one, this is part, okay, this is assembly. If you define part using two simple parameters, height and width, and load this part to your project and place the surface, define the surface, and then these parts gonna be modeled like this way. If you put numbers 10 by 10, total 100 frames gonna be auto generated like this way. This is one way of using that. What if you change the surface? 10 by 10, total 100 frame, but you changed frame. Simply, you want to make this kind of shape for your lobby's huge interior surface panel or interior surface design component, something like this, by using this kind of panel. And then this one auto regenerate this kind of shape by using this part, okay? Any single parts are totally based upon the definition of this one. What if you want to change with this 1 from 2, thicker than this one? Entire parts in this assembly gonna be auto update on time, okay? Without any additional tasks. How about this building? If you create something like this building quickly, I actually made this building in 5 minutes in Vasari. How this building is looking like? Do you imagine some building? Okay, very ugly Seoul City Hall, but I made this one in 5 minutes, and the building surface shape has something like this, okay? And I placed this part in the surface, and Vasari auto-generated in this way. What's different? Take a look at one piece by one piece. Everything has linear panel shape. If this one is kind of max, 3D Max generated, all parts gonna be banded. In that case, how to install flat glasses, okay? If you wanna create some banded glass, too much expensive. You cannot make that building realistic. But every single panel has flat surface. In other words, cheap and easily make standardized glass can be installed, okay? That's another big issue. What if you want to create some different shape of part on different surface? This rectangle shape also has its own parameter, just 2 parameters, but they can be loaded like this way. We're going to make something like this by using Vasari or Revit. And you're going to export this one from Vasari or Revit to 3D Max so that you can create some additional visualization and so on as one of the lab exercises. Anyway, this is one way of using parametric modeling. And I would like to show you another advanced example. Before showing that, I would like to show you this example first. Curtain wall panel system. Actually, curtain wall panel system is one of the representative building facade system nowadays. But this one is not only for building facade issues. Lobby space or even some living or office spaces, building interior totally affected by building skin, building surface system. So as an example, this is Seoul City Hall, and this building construction, I'm not sure the numbers, but anyway, it takes really long time. Simply because of the gap between designer's intent and the construction problems. And of course, there are some political issues, some other issues. But anyway, designers designed by some geometric approaches at the beginning of the project. And this is actual construction picture. And this is the real picture of this building after as-built stage. Now this building is in operation, but unfortunately, this one is kind of one of the worst buildings in Korea nowadays. But anyway, my point here is take a look at this conceptual design model. At early phase of design, architects made this kind of visualization. Architect's intent is simple. This is serial, and we want to make some very broadly, widely opened building skin, and there are some open spaces open to public citizens, Seoul citizens, such as music hall, okay, and kind of accessible and some very special area, and building surface gonna be something non-uniform curtain wall panel system like this. And this is a little bit elaborated model in design development phase. Something different, right? Some level of detail is getting better. But actually, this is the final product picture. Take a look at this truss structure. Totally different from here to there, right? But actually, what if they design by using some parametric and BIM and some constructability considered approaches? The design can be a little bit different. Even if in early phase of design, they can, actually they don't need to see the details, but anyway, this kind of detailed features, structures can be modeled even in early phase of design. That's the point. And I would like to show you another example. This example is kind of not good case, okay? But this one is a good case. This is Dali Museum at Los Angeles, and the project handled by HOK, designed by HOK. HOK is one of the world leading architect firm. Take a look at this building. Just simple box-shaped building, but they put this kind of freeform, non-uniform design shape for the building core and main gate as a main design shape and feature of this building. And take a look at this visualization. This is Revit model, okay? By using Revit, they parametrically defined this structure, and then they can analyze even in early phase of design for in terms of structural analysis, energy, or some load-bearing system, and so on. So this is real picture of interior. Thanks to that non-uniform shape of that building exterior, building skin, the interior space of this building totally changed, okay? From simple box-shaped building to this kind of building shape. I show you this one, this rectangle-shaped curtain panel. There is one single glass panels in rectangle shape. They are all flat. And this frame bar also controllable by using such parametric beam authoring design tool, okay? Even designers know how many panels they designed in this model, okay? One piece by one piece. And then they can manufacture, deliver to the site, and they could install this part. So again, another comparison. You know this screen. This is 3D Max screen, okay? You can generate any type of such building skin, building frame, interior surface panel, surface design by using this kind of geometric shape. Tessellate, editable poly, or put some edges and so on. But also even you can make this kind of non-uniform shape. What if this is a new building designed by you? It's possible. But the problem of this geometric shape is you don't know how many rectangle shapes are designed in this surface. You don't know what kind of control points or which point, which part can be assembled for making this one, okay? That's the problem of geometric design. But still, it is very important and easy for visualization. That's why we are handling this tool. So I think now you can easily understand these two different ways, two different approaches. First one, geometric shape oriented approach. Next one is parametric modeling approach, BIM approach, okay? So this is part, this is assembly. In geometric shape, there is only geometric subcomponents such as vertex, edge, face, shell, okay? That's total different, I can tell you, my point here, okay? So when you are using Revit, we already take advantages of using this kind of parametric modeling features. You load just your desk chair onto your project, onto your assembly, your project, your design, your building. So we're going to move to that issue in the lab exercise hours. But before doing that, please keep in mind that these two different approaches. I'm not talking about we abandoned the geometric modeling. Geometric modeling still has amount of pros, even if it has cons. Free to edit geometric subcomponents and very good and handy to visualize. But it is just a design model, not reusable part. It's not BIM supportive. But parametric model, BIM model, they are very freely applicable to any building, reusable and BIM supportive, very smart way. But it's not easy to handle. There is no way to control sub-components of geometry. And usually, we believe it's not good to visualize. But we can resolve that problem. Export geometry to 3D Max or other visualization tools, and then we can generate very nice renders and so on. They are one of our lab exercise parts, okay? Okay, let's get started again. Parametric modeling demonstration in Revit. I would like to show you some advanced examples of parametric modeling, okay? BIM modeling. Actually, I told you this is advanced example, but actually I have been done those examples 2006, 9 years ago, okay, in Georgia Tech with my colleague Jamin Lee. Actually, this is kind of really advanced one for you guys, undergraduate students. But if you recognize this one is one of the advanced applications of such parametric modeling, BIM approaches, and their advanced uses, and then that's going to be great for your further development. Okay, so curtain wall panel example. Let's take a look at this process and approach example. By using Revit and Revit's family editor, we try to make some specific type of window panel. Okay, window panel, I told you, very important for building facade and as well as interior finishes. So firstly, physically, we need to edit shapes by using family editor and parametric model. Take a look at this plan. This is section profile. Simple triangle shape, but parametrically defined the ratio of this triangle shape and thickness and the depths and so on. Define the geometry and put the parametric constraints. Constraint means simple equation, such as web thickness, web height going to be same to the front seals height and so on, equal, bigger than, or some numbers, okay? Very elementary school level equations for this model. So firstly, we need to create a part based on that rectangle shape panel, okay? And put a bar and another rectangle shape and 3 bars, and then create one single part, and they can be loaded to an assembly or project, okay? So this one can be assembled in this way and can be loaded into project for making a building skin surface, interior panel, whatever. This is fundamental way of creation. Let's take a look at this diagram. This diagram is kind of engineering-like diagram, not design diagram, but I think eventually they are same. We have part 1, 2, 3, and part n. Here, n can be 100, 200, even 1,000, okay? 1,000 parts can be one assembly. And we can put some more parameters, width, height, and so on. So some different type of parts, okay? Connections, horizontal bars, and joints, and so on. They all assembled and loaded into one single project. This is kind of explicitly defined engineering approach for making this kind of shape in terms of design and construction, as well as manufacturing. This is a part, and this is assembly shape. This one can be loaded here. 3 4 by 12, something like that numbers, okay? What if you change this width or bend the surface? This one supposed to be auto updated, okay? That's the way of parametric modeling. Take a look at this example building. Simply generated building design, and this building has this kind of rounded shape surface. This round shape can be adjusted, changed, updated by designer. And we need to install this kind of large scale cutting panel system. So, so this is second example, how to create this kind of example by using Revit. This is the building's floor plan. Take a look at this wall surface. Huge glass panel, okay? And this is actual product. Manufacturer name is Cornell, real company in the US. They produced amount of such cutting panel system, mullion system, Windows system, and this one gonna be installed in this part, even in early phase of design. So for making this, we prepared this kind of process diagram, the same as the one that I showed you before. Parts gonna be assembled and installed in actual project in this wall, okay? So by using family editor, we need to define this object. In Revit, you cannot find out this object, okay? You have walls, windows, amount of doors, furniture, but I told you before, if you wanna install something new, you can define your own object by using family editor or some similar tools. This is that example. So define that one and load into the project and install in your real building like this way. So this is the profile of the wall boundary, and this one can be loaded like this. Simply imagine how to model your wall object. If you click the wall here and drag, the wall gonna be generated. But in this way, this is not wall, mullion system of that real product. It's gonna be installed like this way, this part, and entirely filled in to this surface like this way. So in this way, we can generate this kind of building actual object. What's important? Take a look at this one. Every single horizontal bar has linear lines. In other words, standardized flat glass panels can be installed every single window panel, okay? No need to consider some rounded glass or some other construction issues. And this is Revit screenshot, just simple generated Revit render option. And building, this is lobby scene, interior scene. So this one totally changed the building's interior design too. By using the same example, Cornell example, let me show you another parametric modeling example, also done by me and my colleague in Georgia Tech 9 years ago. Parametric modeling demonstration. At this time, I'm going to show you some Bentley architecture example, not Revit, but similar to Revit, another BIM tool, okay? This is the detailed specification of that product. We are not going to create or manufacture this kind of architectural element. They are all manufacturer provided objects. This kind of company, Cornell, they have hundreds, thousands of their products for window system, curtain system, surface system, and so on. This is 2800 truss wall product name, okay? So based upon this specification, we can plan design process considering constructability in terms of parametric BIM modeling. Firstly, basic section is here, okay? based upon the section, we can create two different frame bars and put this subcomponent web to join two frames, okay? Front frame and the rear frame. And then main assembly can be assembled like this way based upon this process. And then some more additional geometry we need. Some horizontal bar section and the shape. So we can make this kind of assembly. Actually, this is assembly, but this is final project assembly. Even more advanced applications available if we change the section profile or path and so on. So this is the design process diagram, something different, our conventional design process diagram, okay? So take a look at some details. This is front bar and rear bar. What is constraint? The first frame bar has height numbers equal 5, but how about rear one? Rear one's constraint is equal front one, okay? We don't need to put 5, just equal front one. And then if we change the front frame's height, the rear one automatically changed, the same as the front one height. How about the distance between those two webs? Of course, they can be parametrically defined in the same way, like that. I'm going to show you some demonstration. Some series of more issues. Take a look at this actual installation. All they are flat windows, but they are not always linear. We can make some curved skin. In that case, we can put some angle numbers, 86, 85, something like that numbers. We don't need to put every single numbers for each joint. Simply put same, all same to the first one. In that case, if we change, update the first one, all others gonna be changed, okay? So simple change of this number of the angle, all others gonna be auto-changed like this way. That is why we can generate this kind of shape by using some boundary line or section profile and so on. Also, the horizontal bars can be defined by specific height, specific position based upon the total amount of height. And there are some more detailed issues. Take a look at this one, the section. Those two bars are horizontal bar, and within this bar, the window glass is gonna be installed. But if this one has angle, the cut of this edge should be something different, okay, according to the angle. So how to resolve that problem? This is very simple equation, middle school level equation, middle school level mathematics. We don't need to compute very highly developed complex one. If this one always 90 degree, sometimes you meet some gaps or some problems in actual installation. So that's going to be a real big problem on site. But what if we can manufacture one piece by one piece with precise angles, precise numbers? To resolve that problem, simply we can measure the angles, how it's going to be changed. When it's going to be narrow or broad, we can count the angles and lengths, and we can eventually put the parameters like this. Angle parameter is here, and the rest of distance and the others angle side can be measured like this way, okay? So if you want to change one single control angle, all other angles going to be auto-updated, okay? I don't want to show you some details, but you can take a look at some overview. Everything is under mathematics, just middle school level mathematics, okay? That one. So at the end, actual products, this kind of parametric tool, Revit family editor, Bentley architecture, this kind of tool supports this kind of parametric modeling. So this angle totally going with the angle of the surface design, which designers intended to update the design. Okay, this is the output image, and here is the actual glass panel installed visualization and the angle. Every single panel has flat. Okay, it's supposed to be, and horizontal bar, and it's cut, angle cut, all controllable. Okay, like this way. This is one example of final edit, and this is every single property. All these are angles and lengths, height, and so on. They can be controlled by numbers in this way for geometric shape, this design. Okay, so this is Bentley architecture design view. They can be loaded like this and installed like this way. Okay, just one snapshot of that design. For this one, let's take a look at some demonstration video. I would like to show you some real example for that. This is the one that I show you, right? This is Parametric Cell Studio that I used as a parametric design tool, parametric modeling tool. If you click the front frame, this one has parameter 5, okay? And the real one has equation the same as the height of this one. What if you change this one number 10, and then the real one gonna be increased like this way? But this is not valid, okay? So just simply undo it. And what if you change the front one's height to 20, okay? And then real one's height as well as the number of connection webs gonna be auto regenerated thanks to parameters, equations. So change to 15. This one supposed to be within those frames. This one not gonna be installed here, okay? It's not possible. So this one gonna be modeled like this way. And if you click this one, the height and the ratio gonna be measured by using this control point, green point, okay? If we change the distance, auto updated the gap, but in this case, it's in terms of structure, it's not good, so it's not possible. But if we make some narrow distance, auto updated, okay, same distance, simply because that's the parameter. Okay, this is the first example. Let's see the next one. Okay, this is the mullion cottonwool frame, and here is the section, the path of the horizontal bar, and take a look at the modeling of horizontal bar. Every single bar has its own cut according to the angle of this path, okay? What you need to do is clicking the path and draw that object like this way, from start to end like this way, okay? Simply load the object like this way. We define the section profile and angle cut, and everything is linear, so this one gonna be generated like this way, okay? Exactly controlled by parameters, equations, constraints, not simple geometric shapes. The last example is final product example. This is another section profile for make this one. This is 3D object actually, so change the view and amount of vertical frames and horizontal bars already installed. But what if you want to change building surface, curve, angle, ratio, and so on. In that case, simply click the path, and the first angle is 350, and the other angles are currently parameters are all same to the first angle. Very simplified defined. Of course, you can put even more complicated parameters. What if you change 355? In that case, all others auto updated. This one has different parameter system, so this one doesn't affect. But the first wall surface angle gonna be updated like this way. Okay. So this is another example demonstration of this parametric modeling by using advanced BIM technologies. Okay. Next issue is another advanced features when we are using building information modeling. BIM and design applications. Okay. Let's assume that you are designing by using Revit, 3D Max, Rhino, parametric modeler, whatever for your design visualization in design studio, or even in industry as an architect, interior architect, designer. We do design using Revit and BIM tools, advanced tools. What's next? What's available? Actually, not only for design, there are a bunch of more things we can do, okay, when we are using BIM. And the series of examples that I want to show you now is something postgraduate school level, not undergraduate level. But just for your information, I would like to introduce you some snippets of them, okay? This is actual US courthouse building. Architect designed this building by using Revit around 6-7 years ago. And when I was in the researcher in Georgia Tech, as a member of the research team, I developed some series of design review and design validation applications. How to validate this design? In terms of space program review, space program means area, space allocation, number of spaces, and so on. And circulation security checking, and preliminary energy analysis, and cost estimation, even in early phase of design, okay? So this is the area issue. The first one shows you 201, and second one shows you 196, something different numbers, simply because the area of the walls, okay? By using interior finish boundary line, some shrinking numbers area, but if you use center line of the wall, some bigger number of the area. Which numbers we have to take? It's controversial, but there is specific definition. Anyway, according to very detailed area calculation method, we can provide this kind of review chart. This Excel file is auto-generated, not human-generated. What I mean is Revit or some similar BIM application automatically create this one. This one is computer-generated based on that BIM model. Revit knows atrium area is 622, and this one knows number of courtrooms are 9, and number of chambers, number of elevators in this building, okay? Because that is BIM model. So computer knows how many spaces for some spaces of interest, and the area and ratio, building skin area, main entries, floor level is level 2 or ground level, whatever, they can detect it, okay? So this is one example of space validation. And next one is circulation analysis. This is circulation path graph, okay? This graph can be generated by computers. Simply because computers know this space has the door and related to this corridor and another door passing by and go through this space like this way. So usually human measured the line by hand drawing to evaluate this kind of circulation issue, but thanks to BIM, computers can do that. When human did this, 3 months took, but computers resolved this problem in 10 seconds, okay? That's the difference. And thanks to that progress, what happened? Saving money, saving time, okay? And this is some old data space object, okay? I told you in BIM, there are space object without any doors, any walls, slabs. Only by modeling space object, we can create this kind of building shapes. And we can generate additional diagram to review circulation and security issues, okay? Computer knows this red space can be accessible to this green space or not in automation and report it there if it is a problem. And preliminary energy performance analysis. This is energy review thing. In other words, how much energy bills you're gonna get when you build this building, okay? In terms of its energy performance. And the security circulation checking example. And it's very good to choose best design option, best design alternative. This is real case, okay? Real buildings, several alternatives, and review them. Thanks to BIM model, they design all these by using not SketchUp, by using Revit, okay? And then you can review in automation. The same, Revit generated BIM model and auto reviewed result, and then people can choose which one is the best option for this building. Okay. This is the one example. And just for your information, I like to show you another one. In today's lab exercise folder, on the Revit application, let me open this slide just for your information. Let me quickly show you this slide, okay, as the final content of this lecture. Probably you may recognize this building. This is this building, okay, College of Human Ecology building. As you know, this building renewed around almost 3 years ago, right? When we have planned for reconstructing this building, we discussed something about some special allocation. Which department occupies which floors, something like that, okay? At the time, we generate this building, existing building, by using Revit and try to make some additional validation, application, and so on. At this time, I would like to show you some circulation review example. And this is the slide presented to the ISAC 2014 conference last summer at Sydney, Australia, okay? One of my graduate students. This is one of my research topics in my lab as a graduate research topics. But for you guys, for your information, I would like to quickly introduce you. Demonstration of BIM-enabled quantitative circulation analysis, okay? You don't need to know what is better language or something like that. Take a look at this diagram. Conventionally, we use plans, and we design using these symbols, and we review designs totally based upon these plans, okay? Because we don't have anything except those plans, okay? But what if we can do more based on BIM models? That's the issue here. So we made this building by using Revit, and there are 2 or more design alternatives. Those 2 alternatives, we don't know which one is better. But at least we can provide numeric data, quantitative data from those two different alternatives to provide as a reference to measure which one is better. We're not going to tell this one is better or this one. We can tell them the numbers from those design is here, and you can judge which one is better, okay? Thanks to BIM model. Usually design is very qualitative. In your design studio, you always spend 99% your time for expressing qualitative issues of your design. My design is good, and humanism and some commercial, very philosophic, okay? Very how can I say, imagination things, okay? There is no mathematics, no numbers, no engineering. But I told you I'm kind of engineering oriented because I'm design computing majored. Everything can be in numbers, okay? So they can be transferred like this way. So eventually we can provide this kind of comparison graph. Alt A, Alt B, Alt A, Alt B. I'm not talking about Alt B is better simply because it's higher than Alt A. Rather, I tell you the circulation amount of numbers is 100 or 200, something like that. Okay, let's take a look at some details. For that, let me skip this. This is the platform of acquiring such complex data. We don't need to know this complex process. I'm going to show you some type of final result, okay? By using this BIM model, by using this tool, we can generate amount of circulation graph information and past data, and we made some equation. Simply, we can get start space, target space, pass, summation of entire walking distance, summation of number of tons, how many tons you need to get this space from main entry to lobby, elevator, corridor, and the front gate and this room. How many tons and how many angles computer knows, okay? So this is level 5, this floor. We are here now. Based upon this plan, 3D plan BIM model, computer auto-generate entire circulation graph. So this building to my lab has this circulation path, okay? Precisely measured distance and number of tons and which type of space is gonna be passing by, thanks to these BIM tools. And finally, we can get total walking distance 488 meters for this floor, okay? Entire walking distance in every scenario. So for this building, this is before and after remodeling. When we remodel, we model the BIM Revit file for this building before and after, and recreate the circulation analysis like this way. So we got two final design alternatives. Actually, department C in purple color. The purple color here is our department, okay? Interior architecture department. Design alternative 1 has some scattered allocation, and design alternative 2 has 5th and 6th floor allocation. Actually, we used this one, actual construction, but 2 or more alternatives we have at the time. So we analyze those 2 alternatives in this way. Number of total working distance, total tons, and the spaces, spatial depths, and so on, like this way. And we provide this kind of measurement criteria to people for renewing of this building, okay? So this is the final chart. In this phase, we have design geometry, okay? But in this phase, instead, we have numbers, amount of numbers. Okay, I'm not sure which one is better, but at least we can compare them, okay, in terms of circulation numbers, walking distance, and so on. So final chart can be generated like this. they are the source of measurement, source of design review, not this one tells which one is better or not, okay? Because design is always qualitative. But they are very good resources for making better design. That's my point, okay? So this is one example of advanced research, advanced development of by using BIM and advanced design computing issues, okay? Let's get moved to the lab exercise.